Hi, everyone. I guess we'll get started. Welcome to another episode of the Common Lisp Study Group. I'm your host, Ron Batum with Atlanta Functional Programming. Apologize for the late start today. Unfortunately, I was just recovering from a little bit of a sickness, but I'm feeling much better now. I hope all your holidays went well and Christmas went well, and I'm hoping that New Year's preparations are going underway for all of you. Today, we're going to be mainly covering the end of Chapter 7 on student. If you recall, last week we talked about student and its ability to essentially solve word problems that you typically would find in a high school algebra book. Some examples, as you could see on the screen here, include, for example, if you ended up using student to say, compute the number of advertisers that an advertisement ran, given that your our salesperson Tom gets twice is the square of the 20% of the number of advertising he runs, and we computed the number of advertising he gets if the number of advertisements is 45. Um, and you can see that how it approached actually doing this is actually was fairly straightforward. It ended up parsing the natural language text into a set of system of equations that you did the translation using the rules-based translator that we've computed here, much in the same way that we solved GPS as well as ELIZA in terms of natural language parsing. And we ended up realizing at the end of last week's discussion that a lot of these tools in those early days of creating these simple like solvers were little more than just parsing the text that's in a well-defined form into a set of equations that we could then just use simple methods. And in this case, we used a form of constraint propagation to actually go and solve the system of equations. Um, I ended last week with the fact that I mentioned this after we extended this with creating the trice method um, extension to the rules-based translator, that we'll be going through some of the uh, exercises today, mainly with a focus on a lot of the hard problems, just because some of these hard problems are going to be interesting to do. I had to actually go and take a take a hard look at these hard level problems, meaning, no pun intended, that some of them required some thinking. I think I have an understanding of what these problems are trying to solve. I'm only going to address a couple of them, just mainly because a lot of the hard problems, as the author indicated, are actually somewhat more difficult. It will take a little while to actually go through. So, given that this is going to be our last episode of the year, I thought it would be nice to have a little bit of an open discussion while we're going through some of these problems. So, if there's anything Lisp related that you'd like to talk about, feel free to drop a line on the chat window, either through Jitsi if you're on the Jitsi meetup, or through the live stream, and we'll address them as they come by. Couple announcements before we begin. As usual, Atlanta Functional Programming is a meetup group that mainly emphasizes the use of functional programming languages, and functional programming has a dominant paradigm for large-scale software development. Although we are not actually paradigm prejudicial, we actually are paradigm agnostic, and we feel that functional programming is a paradigm that could be uh, used in conjunction with other paradigms, whether it be procedural programming or object-oriented programming, depending upon what language you're using that has these functional features. Um, we are in need for new talks to come up, and we're looking for speakers. So if you have a topic that you are interested in discussing, either an application of functional programming, using some new API or library that you've leveraged, or you'd like to talk about Lisp or Haskell or whatever programming language that you are leveraging that has some of these functional features, feel free to drop us a line. I am Bugram on Slack, functionalprogramming.slack, as well as Atlantis Tech Communities Slack Workspace Tech 404. Additionally, I am Bugram and on the Lisp Discord server for those of you who may frequent that server to actually talk about Lisp. And we will schedule your topic accordingly. Additionally, for those of you who are frequent visitors to our YouTube channel and YouTube stream, if you do like our content, please like and subscribe to our channel so you can get up-to-date information on upcoming talks and um, just topics that we might end up posting on the YouTube channel as we go along. So the first exercise that I wanted to start going through, and this is a bit involved, is uh, is actually a medium problem, just because it's multiple parts, and we can actually attack this in somewhat of a systematic fashion. And this is actually um, just trying out student on some examples that are mentioned in the book. And so, you know, let's check some of them out. So let me pull up my buffer here. Give me just 1 second here. I'm going to create a scratch buffer for this, just so that if we do need to actually do any sort of design or any sort of additional coding, we can do so separately. Sly scratch. Okay. And let's go ahead and run student. Since this is a ding, let's just make sure that we can require student being available. Okay, so now it's loaded. Let's go ahead and then run student on the following thing. Now, if you recall, when we discussed student last week, the student interface that Norvig created, the author created, still requires you to write the word problem into a list rather than uh, trying to create pass in a string like we see there on line 18. The main reasons is either way, whether we did the list or not a list, we would have to end up converting it into an actual Lisp list so that the additional functions can actually go through and do the rule-based translation without having to do the additional step of actually parsing the actual string into a form to which they can actually leverage features that Common Lisp already provides for actually coding. So the first problem is going to be, let's go ahead and see if I can actually get this printed out, copied and pasted. Let's see if I can just do this here and say copy. Nope. Let's see if this actually copied the text. Good. Okay. Let's see, $sign. Okay. Let's move this and let us do this. Okay, there. Okay. Okay, and then so first we created that into a list. Then let's call student on it. And then before we're done, notice that there's going to be a couple of special characters here, mainly the 60 this period here in Lisp is a uh, what's it? It's a special character representing a cons pair, a dotted pair. So if we actually did this way, you'll end up saying student to a dotted pair. So we have to actually go and convert that. So the way we do that is in students interface, we have to wrap these around the pipe symbol, and that's because in Common Lisp, the pipe symbol actually has some meaning as to being a user-defined symbol. Let's go ahead and add a space here because percent, otherwise it wouldn't recognize that as being a percent. Less than the marked price and find the marked price. Let's see what this does. Compilation failed, and that is because I'm sure a comma inside a back quote. Right. So I forgot to also deal with the comma because comma is also a special character in Common Lisp. Okay, let me see if I have, yeah, let's try that again. Okay. Queries to be solved. Hold on, gotta clear this again so I can actually look at this. So let's do that. And just for my sanity, let me, since this is now officially a Lisp list, I can actually see everything here. Let's see here. Okay. So the price is $69.70. Okay, so it has so it computed the fact that 15% less than the mark price means that the price of it is actually 85% of the mark price correctly because it did 100 minus 15 um, divided by 100 times mark, but it hasn't actually determined the um, the actual solution because it could not determine the so the equation is correct, but unfortunately um, couldn't solve it because of the fact that it itself is was parsed into a it doesn't know what the unknowns are. doesn't realize that marked is an unknown that needs to be solved. Um, if I just reword this, let's see what happens. This is the same as saying, what is the marked price? And instead of a period, let's do that. Let's see what happens. Okay, so we need to adjust potentially the rule-based translator to actually um, to handle this, interestingly. Um, let's see what I do if I just take this guy out, just to try some stuff out. Okay, I think I know what the problem is. Um, I know if I reword this to the way the other form was, if I said, for example, ignoring this for a second here, um, if I did this and reworded this to say the following, if the price of a radio is 15% less than the mark price, and the price is $69.70, then what is the marked price? Let's see what happens here. Oh, right, because I added that. I have to do this. Okay. Oh, and I have to also add this special character here. Okay. And we're getting a little closer to this because we have to reword the problem. What is market price? Or let me take this guy out and let's see what happens. So it correctly recognized that the price of marked is equal to 85%. But when I get rid of some of these words, these stop words, um, it changes the equation and it doesn't actually solve the problem. Because unfortunately, here in this case, there's two unknowns. Um, it's not recognizing that what is not a um, is a word that it needs to ignore. So let me go look at the rule-based translator here for a second, just to see how might we be able to fix this. What is no, 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 no. We need to go look at. Here we go. Let me see if I could do this. It converted the find to marked, but didn't actually say that we're going to solve marked. Because toFind is its own rule. I'm wondering if we could just shorten this problem, if we can hack this into actually something that is it. If the price and the price is it, does it recognize the word problem? So it isn't a complete word problem, but it's so it doesn't know what to solve. So let's do that. Um, So the main thing that this we're doing is we're trying to create it into a system of equations where there's only a few unknowns that depend on each other, um, and then the solver will work as expected. So we need to update either the rules to account for this case, or we need to figure out um, the we need to rewrite the problem in such a way that it can be understood by student itself. So a lot of these examples are going to be much the same way. Um, let's try. I mean, this didn't actually solve it, so let's try and see if we could. Um, Let's try something here. Make sure it handles this price. This is same as. Okay. So what we're going to do is we're going to try and see how this rule book is getting translated, and then we could um, we can go through uh, the list of rules. So we start with translate to expression, and please note um, that what translate to expression is actually getting is the word problem without the stop words. So let's ignore this rewording for a minute. And let's go back to the original wording of the problem. And what we'll do is we'll use our REPL to allow us to do kind of a step-by-step debugging. Ideally, what you could also do is you can use a stepper from SBCL, but I like to see intermediate results, so I don't necessarily sometimes do great breakpoints here. I take sub-expressions to try and do kind of a mental model approach to how the execution engine works for the program, and then from there I work my way up because these expressions are fairly well defined that it doesn't necessarily require you to do a lot of like, okay, and more importantly, the stack trace is more or less well defined that unless you're hitting the condition situation, there's no reason for you to actually go in and start like stepping through the code one by one. Um, so let's start here with our noise words. What are noise words? I guess I should say. Noise words, for folks who aren't familiar with the concept, are basically stop words. They are words that are in such common use that, hold on one second, I'm just trying to grab, uh, that semantically it's meaningless. Um, So like is or the without additional context, is or the is a pretty useless word. So they are noise words. If you go and look at the noise word predicate here, we have a list of words that we just tend to um, leverage and we throw out. So if it's a member of any of these words, then it'll just be ignored. So if you see here, if we hit and run remove if on here, it gets rid of more or less everything that is not needed for. Oh, okay. I see what's something here. There is an issue with this. Okay. So let's see that. Let's see what happens if I do that. Okay, it still has an issue with some other stuff here. Let's go ahead and remove that. There we go. We're getting a little closer. Um, price equals 69.70. Price equals to find equals marked. Okay, so got the price. We got so so hold on one second. Let's go back here. Paste that here. Okay, and then let's run remove if noise word p on this, and that's what happens. So got rid of 69. It got 69.70, so that's why it's getting parsed correctly. If it's 15% less than marked parse, it's getting that too. Then find the marked price. Find marked price. So find marked. So find marked will become to find equals this. But to find not having any sort of binding is a little interesting. It doesn't actually work. I guess this is one of the problems that we need to extend. Give me a second here. Wondering if this is actually a problem that you see the problem here is to find is not actually worth requiring. And then let's see what happens if I just change this to what is again. What is marked? Okay, so it just switched it up, but it's not. Um, okay, so we're gonna have to write a routine that needs to solve this system of linear equations. Let's see. So we already have the list of equations. So if I did this, got that, then when I do translate to expressions of this, translate to expression, so it means that we created the form. Okay, this is already a list, isn't it? So if we do create list of equations, what happens there? So this is the same list of equations. Okay, so in solve equations, we're going to have to kind of update how we're doing constraint propagation. So here, so what is one unknown trying to do? Let's remind ourselves of what one unknown does. It returns the single unknown in expression if there is exactly one. So, let's take one unknown for the expression, say, equals price 69.70. What happens? Oh, sorry, I have to write this as a list because this is not a single expression yet. There we go. And the reason is this is not a symbol. Atom is expression. Okay, so let on the list of equations, it takes an equation, then yeah, sorry about this. Power went out. Just reshare. I'm gonna have to start the stream again. Okay, we're back. Sorry, folks who are on the YouTube stream. Fortunately, my power went out like midstream. Uh, uh, I will accordingly update things when I get a chance. Um, Let me first reload because unfortunately, since my power went out, my entire Lisp session got hosed. Give me just 1 second here. I'd have to go to this guy here, access the locations, go to this here, and I believe, oh, this is not the one. I have to go to the other location, then go to this one. Okay. Okay, and let us do this. PIP, and it is having some problems not finding it. Give me a second. Oh, I have to that's right. I can't find it because of the fact that it did not exist when I restarted. Okay, let's try it now. Go set package to being PAIP, and we need to go back in requires student. Requires, by the way, for folks who are just joining us on the stream, is actually a program or function that's part of the PAIP Lisp GitHub repository. It's a utility function that was written to actually load in a lot of these definitions. Um, all right, so now let's go back to here, what I had open earlier, but I'm going to have to reload it myself. Go to PAIP Lisp is here, and then in Lisp, go to student. Okay, so now we have our equations that we wanted to look at. Give me a second here. Let me just readjust this a little bit. Mhm. That's it. Okay. And let us do this. Okay. That on. And folks, just letting you know, I've been notified that I might have more technical problems coming my way. So we'll see how long this stream goes before, because there seems to be other power issues in my neighborhood. Um, so I'm going to try to keep up, as much as I can with doing some of these problems as we go on. And if the power goes out again, I will post on the YouTube link the 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 issues that I was having, and I'll probably record a different session with other solutions that I'm coming up with as we go along. All right, so last time before the outage, we were actually dealing with um, this problem. That's PDF, folks. One second. Let's okay, then pull this up here. Um, all right. Yeah. So we're looking at uh, the price of a radio is 69.70 K if the price is 15% then less than the marked price. Oh, wait. Marked price. Find the marked price. Right? Yes. Okay, so when we did this last time, we noticed that it was creating this set of equations, and we're trying to fix the to find. So essentially what's happening here is if you can think of these as systems of linear equations, we have effectively, we would have to essentially substitute 6970 into the second equation, solve for marked, and then to find will equal marked. But as far as the student solver is concerned, there are two unknowns here, to find and marked. And because to find and marked are both um, uh, unknown, the current constraint solver, which demands to have at least one unknown, only one unknown, it's unable to actually solve everything, so it's just spitting out the equations as is. Why am I getting a warning here? All right. Um, okay. So let us. What was that warning condition coming up? Oh, okay. A prefix to infix. Okay, so what I need to do is do this. Requires path match to force it to actually. Hold on, I'm gonna reload my Lisp just so that these unknowns can go away. Clear REPL. I mean, it worked, but it may not work all the time. Let's see. Set package. Okay. Go up here. Um, Load those two. So now we created 25 warnings, but this still will not cause an issue. Let us try one of the other problems that I've written. Student, if Alice is twice Bob's age, and Bob's age, Bob is thrice Dave's age, and Dave is 5. What is Alice's age? Let's see here. Oh, right, because I'm using. I was doing so good today. Okay, so now let's see here. Did this not have my solution? Oh, my apologies. It looks like it deleted my extension that I wrote. No matter. Okay, we could add that. Okay. Load that up. Solve it. Then see what happens here. There we go. Let's see if I do that. There we go. Alice is twice Bob's age and Bob is twice Dave's age and Dave is 5. Then what is Alice's age? It ends up solving it. So okay, everything is properly updated. Let us go to this one, which is the to find marked. This one here is going to require the same sort of approach to actually solving the other thing that was, what's it, dealing with the system of linear equations too as well. Um, let's see if we could change the solver to actually go in and solve the, so we need to first check to see if we can isolate one of the equations. Um, X an expression on the left-hand side of the expression. Um, okay, so the way to do this is to solve the arithmetic here. And how do we solve the arithmetic, do the arithmetic? Okay, that's right, because we want to make an expression with the left-hand side and the evaluated right-hand side. So, oh, what if we did, um, so the issue is it's unable to take this equations. Okay, so I'm going to have to look at the equations that it's generating. So let's go back to this. Okay, so let's go and look at this here. So to make things easier for us, what we're going to do is we're going to load, we're going to first take this and make this into a parameter. This is our problem, okay? Our problem, okay. Okay, now let's, we don't need that big of a name for it. Let's do words, okay. And just so that everything fits into the nice buffer that's on my left hand side, let's go ahead and do some quick readjustments here. There. Okay, so we have our word problem. Let's go ahead and, oops, not that. Go to scratch. Okay, go here, yank this guy out, and let us do this. I want to actually look at the code of what's getting generated by in solve equations, the sum expression that's being generated from this list of words. So let us do this. Let's store the equations that are getting generated into equations. Okay. Okay. So we now know here this is our word problem. Okay. And these are our equation representation of the word problem. Okay. All right. So the next thing to look at to see how things are getting solved is in here. Let us do the solutions of this equation. Right, this sum expression here. Print this out here, but before I continue, I'm going to move this guy up to the top equation because this is solvable form with current implementation of student. Okay. And by the way, I'm not even solving. There is actually a hard problem that actually generates the system of linear equations. Right now, since this is already dealing with a simpler version of this, there is no reason to actually go and attempt to solve that. Although for that, there are some known methods to actually solve the system of linear equations that I want to go and try and see if we can implement as part of today's discussion, although it might end up becoming another time or later this afternoon in a separate video. So let's see here. Right. So what I want to do is I want to run this guy on our equations. Okay. Okay. Here, let's print this and let's run it. Let's see what happens. Nil, undefined. Oh, equations. Right. Is EQNS. There we go. And right. Let's see what happens with. Oh, right. Because this is a recursive function, we have to substitute let's do this. So what we want to really do is grab. I got it. This shouldn't need to even be a thing. Let's do this. You do not need this to being that. Um, 1 second here. Go. We can actually. We don't need to solve the equation necessarily. What we want to first check out is solve the arithmetic. So we want to see if we can actually so let's get rid of this entire thing. Okay. And let's wrap this as map car map car lambda equation. Let one known today when x let answer. We don't even need to have the answer being to solve arithmetic for, but just so that we can map this to other pieces, we could certainly do this. And now wait. Why is this guy getting okay? Okay, so this works. So let's do this. Print and see what happens. Nil, nil, nil. Okay, so we have to go one step further. Let's do this. In 23, delete that guy. Let's do this here. Nil, nil, nil. So we can't even isolate the equation. So that means x is not solved. Okay, so we need to do this piece even. We need to refine this even more. Let's just do one unknown equation, which means I can even just do this. One unknown and see what happens. So there's an issue with one unknown saying that the first equation is okay. Let me try something here. ELT star 1. That should give us that second one. One unknown. This should give us nil. right? But if we do this, and then we do 1, this should not give us null. This should give us true, because price is the only one unknown car of the previous thing. Why is that also nil? That's the rub. Okay, let me try something again. Do that. Okay, so we need to figure out in the no unknown case which case it's dealing with, because there are two cases here. CPWR progn print first case. We're doing some printf debugging here just so that I don't have to go through and step through it. Okay, so it's calling a recursive call here, which here, let's do, let's further refine this. Actually, let's do unknown p exp true. Okay, let's also wrap this guy around. Again, print exp is Adam, or Adam xp true. And what we'll do is actually make this even better by telling us which are we parsing. A tilde percent xp. So what we're doing is I'm kind of wrapping out to see what no unknown is doing for the first case, because I would have expected it to recognize that price equals 697 technically means that there isn't any unknown. Price is the equation. So it should be able to do the substitution. But I don't know if it's because of the fact that as it's parsing through, it's recognizing that there is exactly one unknown or whatnot. So I'm just checking to see what this execution model is. EXP, RHS, XP. Okay. And calling default case. Okay, so let's do this again. Do car EQNS. Unknown P. So unknown P is telling us that the expression is a symbol expression. And then it's calling the default case because it's returning. This is interesting. It's not even going through the expressions at all. And one unknown expression. Okay. So in this case, it is nil because price is unknown, as far as it can tell. But let's see what happens when we do the other one. Okay, so let's get rid of all these guys because they're not necessary. Okay, so we now know that. Okay, so now let's see here. Um, okay. Unknown P X air returns true. And we can see, actually, let's do this. Format T unknown. Okay. And ideally, if the first one we just saw worked, then here, unknown on car of equations, which we know is price of things, we know that it's true, but we're returning nil. Why are we returning nil? EXP Let me see something here. Oh, right, they're not escape characters. I have to do um, EXP cannot be just EXP. EXP should be something. What is the unknown for this guy? For some reason, the equation isn't being passed in. It's not being rendered by format. Why? All right. It's being returned. So what is being returned when I do this? Uh-huh. It's not returning anything. Just for my insanity's case, let us, instead of returning the expression, return t. All right? What happens? Huh. For some reason, it is not recognizing that I got rid of the print statement. Why is that? Let's see. C, CF. I compiled it. Okay, I'm restarting my Lisp. It looks like something got messed up. Okay. Load this. Set package. PIP. Okay. Go here. MCR. Okay. Good. Then Dave's on list. Um. Oh, because we broke this guy. So we at least know that it was working with Dave is not a list here. If we just did this, and we ran that, nothing. But if we ran this, we still get nothing. Damn. Not actually returning anything. Let's try another thing. Let's do def var res. And let's see if we do a setf on res one unknown, which says that it's returning the expression that it's doing. We should get the unknown. Okay, so what is res? Huh. So let us try one other thing. Let's do this another way. Do def parameter. So we're mainly dissecting these word problems to see what's actually happening between each of these functions to get a better understanding of how these unknowns are being determined for the purposes of trying these other word problems that are in section problem 7.4 for folks who are following us along. Is it 7.4? I believe it is 7.4. It was 7. My apologies, 7.6. Mm-hmm. Let's try simple. Okay. And let us do this. Set of equations now being create list of equations, translate to expression, remove if. Okay, so now let's try and see what happens here. Nothing. But let's try set f res on one unknown ELT equations now 0 on 2, which is haha. So the problem is it cannot, even though there is a equation that has a known value, because that value is a floating point value, we're treating that floating point value as a symbol instead of an actual value. So at least this is what this is my hypothesis is. Let's go and change this to go and verify this. Um, Instead of 69.70 cents, let's make this an even $70. Okay. So now our equations have changed to being this. So we now have the following set of equations in our older word problem that we were working on earlier. Okay. So now if I call equations, this should give us price. Okay, so the problem is we need to go and figure out how to handle special characters. Okay, so that's what they meant, that it wasn't just rewording the problem to handle special characters, it's updating student to handle special characters because special characters don't get handled correctly. Okay, um, okay. Oh, we ran out of time. Um, Tune in next week. Uh, we will be continuing this problem. We'll handle special characters. We'll also handle system equations. We're going to update student to also go and deal with some of the other harder features that they provided. My apologies for the short session today, but unfortunately, due to some technical difficulties, we kind of had to have a brief interruption while we were going through some of these things. So hopefully next week we'll have a more stable um, session. In the meantime, I hope you all have a happy new year and keep lisping. And stay tuned to our Jitsi meetup for new talks and new ideas, as well as looking forward for more future Common Lisp episodes. Thank you for joining. Bye.